Hello dear students, today let us start another new unit from organic chemistry. It's about alcohols, phenols in ethers from unit 11. Now alcohols and phenols, they have the same functional group OH, and therefore first of all we will discuss about these alcohols and phenols together, and then after that we will discuss about these ethers. Now alcohols, they are compounds having the general formula ROH. Now here R stands for an alkyl group or a substituted alkyl group. Now remember, alkyl groups are those which are derived from alkanes. Suppose we have methane in alkane, we replace or remove one hydrogen from here, we get CH3. Methane becomes methyl. So alkanes will give alkyls when we remove one hydrogen from their molecules. So this R here in the formula represents an alkyl group or a substituted alkyl group. And this is the general formula of the alcohols. So these can be considered as derivatives of hydrocarbons in which one or more hydrogens have been replaced by these OH groups. These are called as hydroxyl groups. Hydrogen atoms in these hydrocarbons will be replaced by OH group here. Phenols, on the other hand, have the general formula AROH. AR stands for an aryl group. So these phenols, they can be considered as derivatives of hydrocarbons in which the OH group, the hydroxyl group, is directly attached to the benzene ring. So the simplest phenol will be this C6H5OH, represented by this structure, and other phenols will be considered as derivatives of these phenols. So in all of these phenols, the OH group, the hydroxyl group, will be directly attached to this benzene ring. At least one OH group should be directly attached to the benzene ring, and it can be considered as a phenol. Now let us see how these alcohols and phenols are classified. Basing on the number of OH groups, the alcohols can be classified into monohydric, dihydric, trihydric, or polyhydric. Suppose we have methanol or ethanol. These alcohols have only one OH group in their molecules. This will be called as monohydric alcohols. Now, if we take this ethylene glycol, it has two OH groups, so it will be called as a dihydric alcohol. Any alcohol which has two OH groups in its molecule can be considered as a dihydric alcohol. And glycerin or glycerol, this molecule, this alcohol has three OH groups. So this is called as a trihydric alcohol. Likewise, any alcohol having three OH groups in its molecule will come under this trihydric alcohols. Those which have four or more OH groups in their molecules comes under polyhydric alcohols. So basing on the number of OH groups present in their molecules, alcohols can be classified into these different types. Now the monohydric alcohols, they are again classified into two different types. There are those alcohols where the carbon atom to which the OH group is attached is sp3 hybridized. And there are those alcohols in which the carbon atom to which OH group is attached is sp2 hybridized. So those in which the carbon atom is sp3 hybridized, I can further classify it like this. First, we have the primary alcohols. Represented like this. In these primary alcohols, the carbon to which the OH group is attached is bonded to only one alkyl group. Suppose the methyl group, and the others will be just hydrogen atoms. So the carbon to which OH group is bonded will be linked to only one alkyl group in these primary alcohols. Then we have the secondary alcohols. Here, the carbon atom is linked to two alkyl groups like this. This can be the methyl group CH3 or any alkyl group. The carbon to which OH group is bonded is linked to two alkyl groups in these secondary alcohols. Then we have the tertiary alcohols. In the tertiary alcohols, the carbon atom, the carbon to which OH group is attached is linked to three alkyl groups like this. This will be called as tertiary alcohols. Then we have another type of alcohols in which the carbon atom to which OH group is attached is sp3 hybridized. That means it is joined by single bonds only, but the next carbon is joined to others by a double bond like this. So the carbon atom to which OH group is bonded is sp3 hybridized, but the next carbon is sp2 hybridized. These are called as allylic alcohols. Then we have the next type of alcohols in which the carbon to which OH is bonded is once again sp3 hybridized, but this carbon is joined to a benzene ring or an aromatic ring. These are called as benzylic alcohols. So under the type of alcohols where carbon is sp3 hybridized, we have primary, secondary, tertiary, allylic, and then benzylic alcohols. Then the other one was where the carbon atom was sp2 hybridized. Those which have this bond. Here, the carbon to which OH is linked is sp2 hybridized. One example we can see here. sp2 hybridized means this carbon is bonded to another carbon by a double bond. This type of alcohols are called as vinylic alcohols. So these are the different types of alcohols that we find based on the hybridization of the carbon atom. Phenols also can be classified into different types based on the number of OH groups present. So we have monohydrate phenols, the simplest phenol is this C6H5OH represented by this structure. This has only one OH group, so this will be a monohydric phenol. Now in others, there may be more OH groups. Those where there are two OH groups, they will be called as dihydric phenols. And we have the trihydric phenols also, where there are three OH groups linked to the benzene ring. This will be called as trihydric phenols. Then those which have 4 or more OH groups will be called as polyhydric phenols. Now let us see a little about the nomenclature of these alcohols in phenols. The naming of alcohols in phenols. Now, there are certain points that we need to keep in mind while naming these alcohols in phenols. So, let us see some of those points. The first point to remember is that the trivial or common name of alcohols is obtained by adding the word alcohol after the name of the alkyl group. So, if we have CH3OH, in common name or its trivial name, the alkyl is first named and then it is followed by the word alcohol. So this will be named as methyl alcohol. Similarly, if we have C2H5OH, we have the ethyl group here, so ethyl alcohol will be the name of this compound. So in common system, first we give the name of the alkyl group, then that is followed by the word alcohol. In IUPAC system, name of an alcohol is obtained by replacing the last letter E in the name of the parent alkane, alkene or alkyne by the suffix OL. Let us see how this is done. Once again, let us take this CH3OH. Here, first we write the name of the parent hydrocarbon. Here we have only one carbon, so this will be a derivative of methane. Now, the name of the parent hydrocarbon is methane. When we write the IUPAC name of these alcohols, the last letter E is replaced by the suffix OL. So this will be named as methanol. Remember, in common nomenclature, in common system of naming, this is named as methyl alcohol. But using IUPAC name or nomenclature, it will be called as methanol. Likewise, C2H5OH, the common name was ethyl alcohol. If we use IUPAC nomenclature, here we have two carbons, so this will be a derivative of ethane. Here also, the last letter E is replaced by the suffix OL, so it becomes ethanol. So methyl alcohol or methanol, ethyl alcohol or ethanol. These common names as well as the IUPAC names, they are both accepted. So sometimes you might find this named as methyl alcohol, sometimes as methanol. This sometimes as ethyl alcohol or sometimes as ethanol. So try to remember both the systems of naming. Now, if substituents are present, if there are any substituents present in the ring, but position of the substituents are indicated by numerals, and for this, the longest carbon chain is numbered starting at the end nearest to the OH group. The position of the OH group in other substituents are indicated by using the number of carbon atoms to which these are attached. Let us see an example to understand this. Suppose we have CH3, CH2, CH, CH3, CH2OH. Now in this alcohol, we have a substituent on the main chain. Now before naming, we first give numbers to these carbon atoms on the main chain. And to number them, we start from the side nearest to the OH group. So we start from this side. This will be numbered as carbon 1, this will be carbon 2, 3, and 4. Now we see that in carbon 2, there is a methyl group, a substituent. If substituents are present, they will be named first, and the position of the substituents will be indicated by numerals. So we give the number 2 to indicate that this group is at carbon 2. At carbon 2, we have a methyl group. Then we have 4 carbons on the main chain, so it is a derivative of butane. So we write butane, then the last letter E will be replaced by OL since it is in alcohol. So 2-methyl-butanol will be the name of this compound. Sometimes the OH group may be at other positions other than carbon 1. Suppose CH3, CH, OH, then CH2, CH3. Now, OH group is nearer to this end, so this is numbered as carbon 1. This will be 2, 3, and 4. But this is not a substituent. This is the functional group, OH. So, first we write the name of the word root. That is 1, 2, 3, 4 carbons. So this is a derivative of butane. Then we indicate the position of this OH group. At carbon 2, the OH group is present. So butane 2, and then we write OL. If it is at carbon 1, then we just write butanol. But if it is at other positions, we indicate the position of the OH group also. Now there may be compounds in which there are more than one OH groups. So what do we do in such situations? For naming polyhydric alcohols, that means those which have more than one OH group, the E of alkane is retained and the ending OL is added. The number of OH groups is indicated by adding the prefix di, tri, etc. before OL. Let us see an example here. Now here, there are 2 carbons in the chain. We can number from any side because both of them are similar. So 2 carbons means ethane. For polyhydric alcohols, those which have more than one OH group, the last letter E is retained. And then we add the suffix OL, but before that, we indicate the positions of the OH group. So 2 OH groups, one at carbon 1 and the other at carbon 2. So this we can write as ethane 1, 2, and then since there are 2, we add this di to indicate there are 2 OH groups. So this will be ethane 1, 2 diol. Likewise, CH2OH, CH2OH, and then CH2OH. This is another alcohol. Here we have 3 OH groups. 3 OH groups and 3 carbon atoms in the main chain. So this will be a derivative of propane. So we write the name of the parent chain propane. And then at carbon 1, 2, and 3, there are 3 OH groups. So 1, 2, 3, tri to indicate that there are 3 OH groups. And then lastly, we add the suffix OL. So propane 1, 2, 3 triol will be the name of this compound. That is all for today. We will continue in the next class.